Let's look at this new type of way we can write an equation, which is going to be called the slope y-intercept form. So we've looked at standard form previously. Now we're going to see how we can make use of both the slope and what we're also going to call the y-intercept of a line to write a new form of an equation. Okay, so before we start us off, let's just take a look at these two lines. Take a moment and check, where does the line cross the y-axis? Remember, the y-axis is the one in the middle going up and down. All right, and if we check that out, what you'll see is in the one graph, we have it down here. And if we actually find out the value, that would be at like about -6. And on the other graph, we can see it's right by the 4 where it crosses the y-axis. So this is going to become an important point. And so that's why we're going to have this following definition. So that point where it crosses the y-axis, that's in fact what we call the y-intercept. So I'll give you a moment to write that down. And for example, if we have this graph that's pictured here, follow the line. Where does it cross the y-axis? Right at that point. And so that point, what is its y value? So the y value of that point is 3. Or you can actually determine the coordinates of the point. So since it's on the y-axis, you haven't moved left or right whatsoever. So your x value would be 0, and the y value would be where it crosses, as we said, 3. So this is the y-intercept. All right. So again, you're just identifying where does it cross that axis. All right. So if you're watching this online, you won't be able to do this activity in groups, but we will look at other examples here through the video lesson. Okay, so what if we have a bunch of equations written? How can we figure out the y-intercept? We don't have a picture of the graph. One method of finding the y-intercept is just simply graphing the equation. That works very well. But if we just have the equation, there is also another method. So what we can do is the y-intercept occurs where x is equal to 0. So that is important because that's where the y-axis is. And so if we want to find out what the y-intercept is in these equations, what we can do is just set x equal to 0 in the equations. So let's see what that looks like. So if we have our first equation, y equals 3x plus 2, well, now it's going to be 3 times 0 plus 2. What's 3 times 0? Well, 3 times 0 is just 3. 3 times 0 is just 0. And so you're just left with 2. And so the y-intercept is y equal to 2, or as a point, 0, 2. Okay, let's try that again. Because in this example, it's not going to work out as quickly as we just did it there. There it just plopped right out the answer. So to find the y-intercept, we set x equal to 0. So that's step number 1. So let's rewrite our equation. So 3 times 0 plus 2y minus 4 equal to 0. All right. So if we do that, 3 times 0 is just 0, so you're just going to have left 2y minus 4 equal to 0. And when we're finding the y-intercept, we're always just figuring out what is that y value where it crosses the y-axis. So we need to solve for y. So we can use our solving equations techniques, move the minus 4 over, turn it into plus 4. So you're going to have 0 plus 4, which is just 4. And then again, we have 2 times that value. Do the opposite operation for the 2. Don't erase it like that. But take the 2, move it over. Since it's multiplying by the y, you want to divide that 2. And so you're going to have y is equal to 4 over 2. Well, if you do that division, that's just 2. So we ended up with the same y-intercept, and that's okay. And as a point, that would mean your x value is 0, your y value is 2. So we do sometimes write it in either of these forms. And so it's good just to get used to using both of those different ways. So either just stating directly what the y value is, or stating it as a coordinate. All right. And so now that we've seen what the y-intercept is, we can get into the slope y-intercept form. So the slope y-intercept form, what it says is we can write an equation like the following. Y equals to mx plus b. This is one of the most important equations for looking at lines. And what it says is that if we have the slope of the line, which is our m value, and if we have the y-intercept of the line, which we're going to be denoting with b, so b is equal to the y-intercept, then we can actually, just given those two things, write an equation that would actually give you that line. So if you were to do a table of values, it would match perfectly with the line that has that slope and has that y-intercept. So m and b, those are the key things. Okay. So let's say, what if we had a line has a y-intercept of 3 and a slope of -2? How would we write that equation? So the general equation is y equal mx plus b, where m is slope, b is y-intercept. And so you could rewrite that now as, well, y is equal to the slope of -2. So we write that as -2 times x. And we have a y-intercept of 3. So we add 3 on the end there. And so this equation here is the equation of the line that has those particular values. Okay. What if instead of given those values directly, what if we're just given a graph? How could we find the equation of the graph? And this is where slope y-intercept form comes like very handy. Because what we can do is directly from the graph, it's very easy to find the y-intercept. Just go to the y-axis, see where it crosses. And that's at about -5. So I'll just say y is equal to -5 there. All right, that's the first piece of information. So if we're looking at our general form, mx plus b, we need to figure out what is m, what is b. B is our y-intercept, so b is going to be -5, the y-intercept. Oftentimes I'm just going to shorten y-intercept to y-int for intercept. All right, what's the next thing we need? We need the slope. And, well, we know how to find the slope based off of a graph. Find two, I guess, nice kind of points on a graph, and then see how far across you go, how far up you go. We're going across 3 and up 2, and it's going to be rise over run. So 2 over 3. There we have it. We now have those two key values. And so now we can write the equation of that graph very efficiently as just 2 over 3 times x. And you might be tempted to write plus -5. But remember, if you have two signs like that right next to each other, we can just write that as 2 over 3 x plus and a negative is just the same as minus 5. So you can directly write down the number that you have with its sign after your x value. And that is the equation of that line. And oftentimes, that's something we'll want to know is what is the equation given some sort of graph. Let's take a look at this one. So again, our general form is mx plus b. We need to figure out what is m, what is b, the y-intercept, and the slope. So first, let's check our graph. Go to the y-axis. Where does our graph cross the y-axis? Well, that's, I'd say, at about y equal to 3. And so we replace the b with the 3. All right, next, we find a couple good points that are at, crossing grid points. So that way it's just easier to count how far up and down we're going, how far left and right we're going. So here, we're going to go down 2 units. And then we can see kind of to the right here is a nice point again. So we go across 1. So down 2, so I'll write it as negative 2, across 1. And so if we're writing our slope, rise over run, so our rise is negative 2 over a run of 1. And that's just the same as negative 2, just simplifying things. All right, so now if we write the equation, we can write it as negative 2, that's our slope, times x, plus our y-intercept of 3. And there we have it. Just like that, we have the equation of the line. Okay. So as we saw, y-intercept form is, slope y-intercept form is very useful in terms of being able to efficiently look at graphs, go from them to an equation. And oftentimes we're going to want to turn things into slope y-intercept form. And so that's what we're going to do with these final 2 examples. So if we want to turn something into y-intercept form, we need to make sure we have y just by itself and then equal to some number x plus some other number. So if we're looking at, I'll just leave this up here. We're looking at this equation right now. Y is on the left side, but x is on the same side. We're trying to convert to slope y-intercept form. We need to move that x over to the other side. Right now that x is positive, so we can subtract it and say that y is equal to 3 minus x. But we do want to kind of keep it in the same order. So we can move this x in front of the 3. For moving things just on the same side of the equation, keep the sign that's in front of that variable. So it's going to be y is equal to negative x. 3 doesn't have a sign in front of it because it's a positive number. So since it's a positive number, you can say plus 3. So negative x plus 3. And that is now in that same form as up here, the slope y-intercept form. Okay, let's do the same thing over here in part B. So again, the idea is basically we're moving everything away from y. So you have this plus 2. We want to move that away from y, which is going to be subtract 2. And then we still have this dividing by 4 next to the y, or with the y. So with that being there still, we need to also move that thing to the other side. So we need to multiply the other side of the equation by 4. All right, so what do we do when we multiply that other side by 4? So we need to be careful here, because it's not like we're going to just pick one number and multiply that one number by 4. If we move something and there's multiple parts on the other side of the equation, and we're doing something like multiplication, we need to multiply each and every part by that particular number. So it's going to be, let's say, we have negative 3x. So we're going to have negative 3x. And I'll just write times 4 in brackets with brackets. And then we're going to have minus 2. And again, times 4. So all of the parts are being multiplied by 4. And now we can simplify it. So negative 3x times 4, we just have to multiply the numbers together. So negative 12x. 2 times 4. Well, that'll just be 8, so we're just subtracting 8. And so there we have it, our equation now in slope y-intercept form. So the x, the number, are on the other side of the equation as the y. All right, and there we have it. That's a summary of slope y-intercept form and the number of different ways you can make use of it.